Okay, good morning. So let us continue the lesson. Let me start from the example that we left as an exercise for you. I don't know how many of you have thought about it, but let me start with that one and give you one more example and then continue to apparently a little bit different approach. There is something that I want to talk about today is about algebraic inequalities, okay, and then how they are related to actually the topic of vectors here in this case. So if I am right, that was the question. Is there any vector that makes an angle 45 degrees with the x-axis? So do you remember the alpha, beta, and gamma are standard notations in this case? They are called direction angles. So this question is asking you, is there any vector so that its alpha angle is 45 degrees and it makes an angle 30 degrees with the y-axis, yes? So it means that, is it possible to have a vector whose alpha angle is 45 and its beta angle is 30 degrees? That is the question. Do you think that there is such a vector or not? Do you remember we had a formula for the cosine of the angles? They are called direction cosines. We know that cosine squared alpha, cosine alpha squared plus cosine beta squared plus cosine gamma squared should always be equal to 1. Yes? If alpha, beta, and gamma are the angles that a given vector makes with these axes, this is the relation that we got yesterday. Okay, so if alpha is going to be 45 and beta is going to be 30, let us plug them in this equation and see what happens. So this becomes cosine of 45 degrees squared plus cosine of 30 degrees squared. And then, of course, we don't know gamma, but let us see how it works here. And then if I ask you what is cosine of 45, it is 1 over square root of 2. I am squaring it, so this gives me 1 over 2. If I ask you what is cosine of 30, it is square root of 3 over 2, yes? Square root of 3 over 2, sorry. And then you have to square it, which becomes what? 3 over 4, and then plus cosine gamma squared equals to 1, yes? But if I add these two numbers, so let me move these numbers to the right and try to find gamma, yes? So this becomes cosine gamma squared is equal to 1 minus a half minus 3/4. And if I take the common denominator here, 4, this becomes 4 minus this becomes 2, and then it becomes minus 3. And then what happens, 4 minus 2 minus 3 is minus 1 over 4. Yes, and that is contradiction. Yes, because cosine gamma squared cannot be a negative number. So the answer to this is simply no. There is no such a vector. Because if there is such a vector, we should also have a gamma. Yes, when you have a vector, that vector makes an angle with the z-axis, that is for sure. And then if you want to find, on the other hand, you know that this relation holds. But if you want to calculate that gamma, you see that cosine squared gamma should be a negative number, which cannot happen. So we cannot have that gamma. Yes? So this cannot happen. So the answer to this question is no. Is there any vector that makes an angle 45 degrees with the x direction and makes an angle 30 degrees with the y direction? The answer is no. Because if there is such a vector, the angle that vector makes with the z-axis should satisfy this equation, but this equation is not satisfiable, yes? It's not possible. If you want to imagine it from graphical point of view, for example, if I give you this line, yes, and I ask you to imagine all the lines making angle 45 with this line. What are those? What can I say about the position of those lines? Yeah, this is a fixed direction. I don't change this one. But then I'm asking you, for example, this is one of those, yes? For example, assume that this angle is really 45 degrees. This is one of them. Okay, if I want to consider all of them, how should I imagine them? This is one of the lines that make, for example, 45 degrees with this direction. Yes? If I want to imagine all of them, how should I imagine them? Yes?
Like a cone?
Yes, it would be the surface of a cone, yes? So it means that I have to rotate it, but I'm not allowed to change in this direction, so it becomes a cone, more or less a conic surface. So it means that I should have a conic surface around the x direction, and I should have it with angle 45, and then I should have a conic section, conic surface around the y direction with 30 degrees. And this tells me that there is no intersection between these two conic surfaces. Yes, because if there is an intersection between those conic surfaces, then that line would be a line making an angle 45 with the x direction and 30 with the y direction. These flies are actually, I don't know what they want from us. Yes, they're really big.
Oh,
yeah, they're killing me here in the aula. Okay. Anyway, apparently we have to live with them. Yes, one of them is here. Okay, so now let me ask you another question, and then we go to the next topic, and then this will be finalized hopefully today, and then the cross product will be left for after the break. Let me write this example here for you. Let V be a vector that makes angles sine inverse of square root of 15 over 4 makes angles sine inverse square root of 15 over 4 and pi over 4 with x and y axes respectively. Determine the angle that this vector makes with the z-axis. So you know that sine, I'm working in radians, of course, and I give one angle as sine inverse of a number, yes? First of all, is this acceptable or not? Square root of 15 is a little bit less than 4, so this number is a little bit less than 1. If I give you a number larger than 1, of course that will give you an error, because sine cannot be larger than 1. So sine inverse, I want the exact value, so you shouldn't use calculators. Of course, you can get a feeling of that angle by putting it in the calculator, but here I want always to work with exact values. So I want you to learn how to work with this one itself, yes? So I have a vector v, it makes an angle sine inverse square root of 15 over 4 in the radian units with the x-axis, and it makes an angle pi over 4 with the y-axis. My question is that now I want you to find the angle that this vector makes with the z-axis. So what I'm supposed to do, at least the starting point should be clear, yes? What is the starting point? Yes?
You can use the formula.
Yes, that's the starting point. So let us start with that. So I would say that cosine, so here, if I want to write it in the more compact way, I would say alpha is given to be what? Sine inverse of the square root of 15 over 4. And beta is given to be pi over 4. What is the problem is asking for is gamma. Yeah, it's clear that I have to start with that relation that I have. So it becomes cosine alpha squared plus cosine beta squared plus cosine gamma squared is equal to 1. The point is that I don't have any problems here because if I ask you what is cosine of 45, either you have it in your memory or you can look it up. But here, there is nothing here. Either you should use your calculator, which will give you probably not very exact value. Of course, might be you have a better calculator, it can give you the exact value. But the point is that without calculator, I want to find the exact value of cosine of alpha. Alpha is an angle which is sine inverse of a number. So how should I do that? So you see here, if I ask you what is cosine beta, you answered 1 over square root of 2. And this is exactly that is wanted, so I need to know this one. Then I will have only one unknown, and that is gamma, and I will be able to find it. So the main point here is not actually this lesson, is how to work with this in trigonometry. So my question is that alpha is this number. What is the exact value of cosine squared alpha? Yeah, I can give you a little bit of time to think. Okay, any ideas? Yes?
The sine of alpha equals to root of 5.
That is the meaning, yes? So when you say that, that's correct. When you say that alpha is sine inverse of the square root of 15 over 4, what does it mean? It means that alpha is an angle whose sine is that number, yes? That's the meaning of sine inverse. So let me ask you, do you have any problems understanding this part? Do you agree that I can go from here to there? Yes. Everyone? Okay, and then it is a very simple problem in trigonometry, yes? Because you have a formula, hopefully this is a very famous one, sine alpha squared plus cosine alpha squared is equal to 1. So that is very famous. Now, I don't need to know alpha, but I know sine alpha, and that is enough for me to find cosine squared alpha, yes? So what I do, instead of sine alpha, I put that number in, so square it becomes 15 over 16 plus cosine alpha squared is equal to 1. Then I move this one to the other side, so cosine alpha squared becomes 1 minus 15 over 16, which becomes 1 over 16. Of course, if you want to find cosine alpha, you have to put plus and minus. In this case, you don't need to be worried about that, but in general, if I ask you what is cosine alpha, you should be able to answer that. Plus or minus. So this, I write it with a different color, because here I don't need it. What I need is just cosine squared alpha, yes? But assume that you really need cosine alpha itself. You cannot say cosine alpha is plus or minus 1 over 4, but which one is acceptable? It might be, let me see if we can do it right now, but okay, so if cosine alpha is negative, so where alpha is, if I choose the negative value, then alpha will be where?
In the second
In the second or
third.
or third. Yes? In the second quadrant, sine is positive, of course. Yes? Yeah. Yeah, that is a little bit tricky. So probably you cannot. Yes.
But we're talking about vectors, so it can only be the second quadrant. Because the angle between... Oh, but it isn't between vectors.
Yeah, that's also between vectors, yes, because alpha is an angle between the vector and the x direction. But instead of x direction, you can imagine the I hat. That is the angle between two vectors, yes.
Because then we can restrict it to the second quadrant.
No,
Because the angle between two vectors can't be more than 180, right?
Yes.
So therefore we can say that it's only the second quadrant.
So alpha is in the second quadrant, yes. Yes, I can say that alpha in principle is from 0 to 180. So either it is in the first quadrant or the second quadrant, yes? So it means it will not be in the third quadrant. But then in the first quadrant, cosine alpha is positive, sine alpha is also positive. But in the second quadrant, that is my problem. In the second quadrant, sine is still positive. So by knowing this, probably you don't know that is this angle in the is it in the first quadrant or in the second quadrant. But of course, I know that this angle is in the first quadrant by a convention. Okay, sine inverse. So let me talk a little bit about here. So if I ask you what is sine inverse, let me make a very simple angle, 0.5. I think so you might have it in your memory. Can you remember that? In degrees. Let us talk in degrees.
30.
It is 30 degrees, yes? So, but let me ask you something else. Okay? If I ask you to calculate sine of 150, what is this one? Sine of 150 is sine of 180 minus 30. 150 and 180 are supplementary angles. The sine of one of them is equal to the sine of the other one. So this is also 0.5. But if you punch this in your calculator, you will never get 150 as the answer. Even though, if I ask you what is the sine of 150, that is exactly 0.5 again. But why the calculator only gives you this one, but not 150, that is the convention. Okay? So the range of this function is somewhere between minus pi over 2 and pi over 2. So, or between minus 90 degrees and 90 degrees. So if you put sine inverse with any number here, and you ask the calculator to calculate it, it will always give you a number in this range from minus 90 degrees by 90 degrees by convention. So that is the definition of that function sine inverse. So even though technically sine of 150 is also 0.5, so in principle sine inverse of 0.5 in principle could be 150 as well, but the calculator will always give you this, and that is because of the convention for defining this function in this form. Yes? So it means that, and then it is clear, if you give a positive number, it gives you an angle between 0 and 90, and if you give a negative number to sine inverse, it gives you an angle between minus 90 and 0. Okay? So then, here I have given a positive number to sine inverse, and that angle will, by definition of sine inverse, it is in the first quadrant. And in the first quadrant, cosine is positive. So if I want to insist to find cosine alpha, I have to choose the positive one, not the negative one. But based on what you said, it is not clear. Yes? Because when you say alpha should be between 0 and 180, there is a chance that alpha is in the second quadrant. And in that case, cosine, I should take the negative value. But if it is in the first quadrant, I should take a positive value. So it means that that is not enough to conclude which one is which. So this is important to know. But here, you really don't need to be worried about that. It's good to know. Okay, if you want, I can write them here for you. So sine inverse, if you want to know the range, sine inverse of any angle, let me call it x, it's always between pi over 2, minus pi over 2 and pi over 2. These are the conventions for these functions. This is by convention between 0 and pi. There is a reason why they have chosen these conventions, but let us not delve into it, okay? But if you want to at least have some information, these are the ranges for these inverse functions, yes? Okay, so it means that now I can solve my problem. I go back here, instead of cosine squared alpha, I put 1 over 16. And this one, I can calculate it. Cosine beta is this number, square it becomes 1/2. And then I will have cosine squared gamma equals to 1. So 1 over, I move everything the other side. So it becomes 1 minus 1 over 16 minus 1/2. I take the common denominator to be 16. 16 minus 1 minus 8, so which is 7 over 16. And then here, cosine gamma, you have to consider both sides, yes? Plus or minus the square root of 7 over 4. Because as Kevin mentioned, gamma in principle could be in the second quadrant or in the first quadrant. If it is in the first quadrant, then I will have the positive value. If it's in the second quadrant, I will have the negative value. Yes? So both of them are actually acceptable. But then I want to find gamma. So what should I do for gamma? So gamma will become cosine inverse of one of these numbers. Yes? Yes? That is your gamma. So it means that there are two possibilities for this vector. Yes? Could you imagine that there should be two answers, not one, before doing the calculations? Because you see, I have fixed two angles for you, alpha and beta. When I fix two angles, what will happen? So here, if I want to imagine it, for example, let me draw it a little bit differently if I can. So let us assume that this x direction goes into the whiteboard, and then this is my z-axis. Okay, and then I have a vector here. So I have a vector here. This is my vector b. Okay, if I have this angle fixed alpha, and if this angle is fixed beta, so what happens? I can have two angles for the other one, because if I consider my vector in this, pointing in this direction, then this will be my angle, gamma. But I can consider the same vector, but pointing in the other direction. Yes? And then in that case, this would be my gamma. That is why one angle is positive and the other angle is negative. So even before calculation, you should be able to understand that you will get two answers. Yes? Because if I give you alpha and beta, do you agree? So alpha and beta fix a direction for me, but not in which direction it is pointing. I can take it in this direction, then gamma would be this smaller angle, or I can consider that gamma, so I can consider that this vector is pointing the other way around, and then I need to consider this as my angle. Yes? So this is why I should expect two angles. Okay. Now let us start apparently a little bit different topic here, but then I will relate it with the vectors at the end. Okay? So I want to talk a little bit about inequalities. So what do I mean by inequalities? Of course, we can consider two types of inequalities. One inequality, I ask you to solve it. Yes, for example, I ask you to solve this inequality. What do I mean by that? I mean find all possible values for x so that when I replace x with those values, the left-hand side indeed becomes greater than or equal to 5. And you'll learn how to solve them, but you didn't learn to solve a little bit more complicated ones, unfortunately. I don't know why that is missing from the Swedish curriculum. That is actually a really important tool. But anyway, so if you want to solve that, 2x, you move it to the other side, it becomes 4, and then you divide by 2, x is greater than or equal to 2. The only thing that you need to be careful when working with inequalities, solving inequalities, is that if you want to divide or you multiply by a negative number, you have to remember to flip the sign, yes? But sometimes I'm not asking you to solve it, I'm asking you to prove a particular inequality holds whatever you choose for the variables. This is one of those things we want to talk today. For example, I can ask you to show, I want to show that for every real number a and b, for all a and b in the set of real numbers, I want you to prove for me why do you expect that this is greater than or equal to 2ab. I'm not asking you to solve this inequality. I'm claiming that this inequality holds regardless of your choices for a and b. In other words, any number that you choose for a and b, always this number is greater than or at least equal to 2ab. It cannot be less than 2ab. Why is that? Yes?
You move 2ab to the left.
Yes.
Factorize.
Yes. So what you are doing is exactly, this is what I want you to understand. So instead of proving this inequality, you are changing the form of inequality. Let us say, so Dylan mentioned that I move this to the left, so it becomes a squared minus 2ab plus b squared, and then what is left on the right hand side is 0, and then this is probably very familiar for you now. It becomes a minus b to the power of 2 squared is greater than or equal to 0. Okay, it was not that easy to realize that this is true, but every one of you hopefully agrees that this is true. Why? Because no matter a and what I'm choosing for a and b, this is a square of a number. It cannot be negative, but of course, in some case, it can be equal to 0 when a is equal to b. Yes? But there is something that you need to be careful. Because this is true, there is no guarantee yet that the original one is also true. Unless what happens, this is important for me I want you to understand the logic. So instead of proving this, I simplified this algebraically, and I reach to something that is guaranteed for me to be true. Then I am claiming that, okay, because this is true, the original one is also true. From the logical point of view, there is a big if. Yes, why if this is true, it guarantees that this is true. You see, the logic is the other way around, yes? Because I want to prove this, I actually prove this one. But why this is enough for proving this to be true? So let me put these arrows. From here to here, I can put this arrow. So it means that if this is true, I conclude this is true. And if this is true, I can conclude this is true, yes? Full stop. But do you agree that I want something the other way around, yes?
Is it maybe because we're in the set of real numbers?
No, that is not the reason. The reason is that all these arrows are reversible. Okay? So here, if you start from here, can I go back? Yes, I can expand. If I have this one, can I go back? Yes, I can move this to the other side. So this in mathematics means equivalent. So this statement, whatever it is equivalent to this statement. And this statement, whatever it is equivalent to this statement. What is the meaning of equivalent statements? Two statements P and Q are called equivalent if they are both true or both false simultaneously. That is the meaning of equivalency of two statements. Yes? So this statement and that statement are actually equivalent. So it means that if this is true, this is true. If this is false, this is false. And the other way around. That's the meaning of equivalency. But now because this is true, and because this one is equivalent to this one should also be true. Yes? So that is the logic behind that. Understandable? Okay, let us improve our skills a little bit of proving inequalities. Very, very simple ones. Okay? For example, this is always the case that if I add two numbers, positive numbers, so let me write here, for all A and B belonging to the set of real numbers, but let me put a positive here, I mean positive real numbers. It's greater than or equal to square root of AB. We want to show that this is always true if I choose positive numbers A and B. By the way, before going back there, let me come back and make it something very clear here. This claims that a squared plus b squared is always greater than 2ab or sometimes equal to 2ab. Can you tell me when this becomes equal to 2ab? When this becomes exactly equal to 2ab, what is the condition that I have to impose on a and b to guarantee that a squared plus b squared is equal to 2ab? Yes? They have to be equal. Why? Because imagine in your head, instead of inequality, you have equality all the way. This again will work. And then, so this means that this becomes equal to this, if and only if this becomes equal to this. But when this becomes equal to 0, when a and b are equal. Yes? So that's also very important to realize. So usually people ask you to prove an inequality like that, and they ask you when the equality sign holds. So you need to be able to answer that one. So let us practice this here. First of all, I want you to prove that whatever a and b are, if they are positive, then this one is greater than or equal to the square root of ab. By the way, there is a name for this in mathematics that is called arithmetic mean, which is just a normal mean, and this is called geometric mean. Yes, so this tells you, this is called arithmetic geometric inequality. This is just, it is true for any number of positive numbers, not only two, but proving it for higher one are hard actually. But this is very simple. This tells you that if I give you two numbers, if you find the arithmetic mean of those two numbers, and if you find the geometric mean of two numbers, arithmetic mean is always greater than or equal to the geometric mean. Okay, so why is that true? So if I want to solve this, if I want to convince myself of that, it is hard to imagine how can I do it immediately in this form. The natural thing is to start simplifying that, but you need to be careful. All the steps that I take to simplify should be reversible. That is the crucial part, yes? So what do you think I should do here? Yes?
Square.
We can square it because, for example, I want to get rid of that, yes? So if I square it, what happens? It becomes a plus b over 2 to the power of 2 greater than or equal to ab. Yes? So first of all, let us go in this direction. If you start from here, it's a valid step to take this, yes? It's valid to take this step. And then what should I do? For example, I can expand. I can write this 1 to power 2, which becomes 2. ab plus b squared divided by 4 greater than or equal to ab. I multiply everything by 4, for example, to get rid of the fraction. Yes? And then I move it to the left. 2ab minus 4ab minus 2ab, and then plus b squared greater than or equal to 0, and then this means a minus b squared is greater than or equal to 0. Yes, and it's a good point to stop here, but you see, I started from here, I concluded this one. Okay, so this is true. But the point is that the proof is not finished here. You need to check. All these steps are reversible. Are they? So going from here to here is possible by expanding. Going from here to here is possible because minus 2ab can be written in this form. Yes, I can add 4ab to both sides. Going from this step to this step is also reversible. Yes, because you divide by 4. Going from this step to this step is also possible because you can factorize it. But going to this step is crucial, and this is guaranteed here because I have chosen a and b positive. So you see, this is necessary to choose this one positive. Yes? So then it means that this is also reversed. Okay, so this means that, all of these arrows are reversible, and the last one is true, so this means that this one is also true. And then I ask you, when do you think the arithmetic mean becomes equal to the geometric mean? Arithmetic mean of two numbers becomes equal to the geometric mean of two numbers if and only if what happens? If and only if what happens? So you need to understand it in this way. Change this sign to equality. Every calculation will remain valid until the very end. And then this becomes 0 if and only if A is equal to B. So if you want to make a geometric mean equal to the arithmetic mean, you have to choose the numbers equal. There is no other way to do that. Is that clear? Okay. So I remember when I was at your age, this was very challenging for me, but the solution is very simple. Can you convince me that this is always true? Yes. It was actually, so I remember it from that age. So we want to prove that a squared plus ab plus b squared for any real numbers, not positive. Of course, for positive numbers, there is nothing to prove, yes? A squared plus b squared is already positive. And if I choose a and b positive, then it means that yes, I am done. So, but I want to show that for all a and b, even negative numbers, I want to show that a squared plus ab plus b squared is non-negative. And I want to tell me when it becomes equal to 0. What conditions should be there to make it equal to 0? Okay, you can think a little bit so that I clean the board. Okay, any ideas? Yes?
Minus 3 on both sides.
It doesn't work. Because I can check, because minus 2ab.
No, minus 3ab.
Okay, minus 3ab. So then it becomes a squared minus 2ab plus b squared is greater than or equal minus 3ab.
Yeah, and then
Yes, and then this becomes a minus b squared is greater than or equal minus 3ab. But this is not guaranteed. Yes? Because might be a and b are different signs. So ab becomes negative, and then by this negative it becomes positive. You are claiming this positive number is greater than a particular positive number, which is not guaranteed. It might be true, might be false. Is that understandable? That's good to understand that there is a flaw in this. Because minus 3ab is not a negative number. If it's guaranteed that's a negative number, that's okay. For example, if I tell you that a and b have the same signs, then you are right. Because if a and b have the same signs, ab becomes non-negative, and I multiply it by negative 3, it becomes negative. And this is guaranteed that a positive number is greater than a negative number, I am done. But if I want to consider all of them, so for this case it doesn't work unless you want to solve it case by case. Yes, is that clear? I want you to understand why there is a flaw in this argument. Yes, is that understandable? Okay, so let us forget about this. This apparently doesn't work. Okay, how should I prove this? There's a simple trick for that, yes? Multiply everything by 2. I want to wait again. Multiply by 2 so that what happens, yes? Can you complete it by multiplying it by 2? Is multiplying by 2 reversible? Yes, because you can divide by 2. Yes, did it work? So let me multiply everything by 2 because I have to reach to the other part. So this I multiply by 2. Okay, so this is reversible. Because if I start from here and get this one, I can definitely go back by dividing by 2. Yes? But then what? Yeah, let me write it. I would write a squared plus b squared plus a squared plus 2ab plus b squared. Is it clear now? Instead of 2a squared, I wrote it as a squared plus a squared. Instead of 2b squared, I wrote it as b squared plus b squared. But this part is familiar, yes? What is that? It's a plus b squared. And then I have a squared plus b squared. Is it guaranteed now? Is it true or false, the last one? It's true, because a squared is non-negative, b squared is non-negative, a plus b squared is non-negative. I am adding 3 non-negative numbers, so it is non-negative. This is guaranteed, yes? So this is true. But I hope that you agree with me, all these steps are reversible. Do you agree? So this means that that is equivalent to that one, that is. So the trick was very simple, but a little bit strange. But let me ask you one question. When this happens, a squared plus ab plus b squared equals to 0, if and only if, what? Because this tells you that this is greater than or equal to 0. It is always good to understand when it becomes the minimum. Yes, the 0. When it becomes 0, can you answer this question now? If and only if. Whenever you want to answer this, you shouldn't get confused. Think you are replacing this with equality sign. I hope that you agree that the algebra remains the same. But every time that you have this sign, you have equality instead. So if I change this to equality, in an equivalent way, I can reach to the final step, which is equal to 0. Yes? So then when this becomes equal to 0, it is non-negative, non-negative, non-negative. The sum of 3 non-negative numbers is supposed to be 0. This cannot happen unless each one of them is non-zero. Because if one of them is greater than 0, because the other ones are non-negative, it becomes definitely greater than 0. So if the sum of some non-negative numbers is equal to 0, there is only one way for this to happen, and that is each one of them individually should be 0. So it means that a and b has to be equal to 0. Yes? So this happens if and only if a is equal to b is equal to 0. Don't take this very trivial. Because you say that this is very clear, but back if I choose a and b equal to 0, then the left-hand side becomes 0. So that is very, very simple. Why you are talking so much? Why is that? Because the other way around is not trivial. There is no guarantee if this is 0. A and b has to be 0. We have proven that that is equal to 0. Is that understandable? Exactly like here. If a and b are equal, the left-hand side becomes a plus a divided by 2, which is a. The right-hand side becomes the square root of a squared. A is positive, becomes a. This is not the hard part. The hard part is that if this becomes equal, they have to be equal. It is clear that if they are equal, they become equal. Yes? If a and b are equal, this is guaranteed that this equality will hold. The point is that if the equality holds, then what happens? We realize that if the equality holds, a has to be equal to b. Okay? Now let me just, the reason that I brought this up, because I wanted to warm up a little bit about techniques and tricks to solve inequalities. Now I want to talk a very, very important inequality in both physics and mathematics, and that is called Cauchy-Schwarz inequality. I have always problem writing Schwarz, I think. There is no T. I think I have it somewhere here. Let me make sure that I haven't done it wrong. Yeah, I think it should be correct. Yes, Schwarz, SC, yeah, that's correct. So Cauchy-Schwarz inequality. Okay, and that inequality is this. For all A, B, C, X, Y, and Z in the set of real numbers, if you calculate AX plus BY plus CZ and square it, it becomes less than or equal A squared plus B squared plus C squared multiplied by X squared plus Y squared plus Z squared. Yes? So that is called the Cauchy-Schwarz inequality. For the time being, there is no connection between this topic and vectors. I will connect them hopefully at the end of this session. But this is, for the time being, is just an inequality in algebra. My claim is that whatever you choose for these 6 numbers, A, B, C, X, and Y, and Z, if you calculate this, it is always less than or equal if you calculate this. Yes? So we want to prove this. Okay, now you have a little bit of experience how to prove algebraic inequalities. This is complicated and not trivial. So what we have to do, we have to simplify this somehow and reach to some point which is guaranteed to be true for us, and then check every step that we have taken to that point is reversible. Yes? So I don't know, do you have any idea what to do? I can give you a little bit of time. It's good to practice a little bit yourself. That is the same idea. These inequalities were simple. The algebra was not that complicated. The algebra of this one would be a little bit more complicated, but it should be manageable because that is elementary algebra. Yes, at most you want to expand this 3 times 3 times, so it becomes 9 terms. And then you can square it. I don't know if you remember the formula for squaring trinomials, you can use that. Otherwise, probably you can do it in 2 steps. Yes? At least try to think a little bit about that. If you don't mind, let me write this for you here if you have forgotten. It's also good to remember because it's not hard to remember. If I have a trinomial, let us say A plus B plus C squared, of course you can do it in 2 steps, but it is easy to remember. The first one is squared, the second one is squared, the third one is squared, and then 2 times the first one times the second one, plus 2 times the first one times the third one, and finally 2 times the second one times the third one. It's easy, and you can write the same thing for 4 terms, for 5 terms. The pattern is the same. So it is important to remember this simple algebraic identity as well. Okay, any progress? Could you solve it?
I need some more time, I think.
Okay, I can give you a little bit more. If you could solve it, I can follow yours, yes? So just tell me what to do.
So first you square the left side and you
Using this
multiply-
identity.
Yeah,
Okay, so let us
and
do it step by step. This one squared plus this one squared plus this one squared plus 2 times the first one times the second one, and then 2 times the first one times the third one, plus 2 times the second one. Okay, and then what happens? Less than or equal to, okay, then what?
Then you multiply the right hand side.
Okay, so you expand that one as well, so this becomes a squared x squared plus a squared y squared plus a squared z squared plus b squared x squared plus b squared y squared plus b squared z squared plus c squared x squared c squared y squared c squared z squared. Yes. So what you said, actually, I expanded both sides. On the left-hand side, I could use this inequality, this identity, or I can just expand that anyway. And on the right-hand side, I did that one. So I have a very big number of terms. So what should I do with this number of terms?
You should cross out the a squared x squared, b squared.
Okay,
y
so
squared.
this one, from this case, from this side, and that one are gone. I can move one of them to the other side. this one is simplified with that one, and this one is simplified with that one. Then
I moved all the terms to the right.
to the right. So this means that this will remain 0, because you are telling me that move these 3 to the right. Then what is left here is 0. What is there is a squared y squared plus a squared z squared, and then plus b squared x squared plus b squared z squared plus c squared x squared plus c squared y squared, and then minus 2abxy minus, let me write here, minus 2acxz, and then minus 2bcyz. Yes. So let me draw a line here. Yes. So 0 is less than or equal to this combination. But is this guaranteed to be true? If yes, why?
Now you have the trinomial square on the right hand side with the minus signs.
Yes.
So you write it as ay plus bx plus cz squared, and then plus the other sign, or the other ones that are.
That I don't know. Let me try to understand you first. What did you say?
So you have the trinomial.
This one?
Yes.
Okay.
On the right hand side.
The trinomial on the right hand side should have only 6 terms. How many terms are involved? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how do you want to manage that 9 terms into that?
You take it ay and bx and cz.
Okay, let me. I want to follow for you. So ay, and then bx,
and cz.
cz, and then write squared.
Yes.
So let me see how many terms are involved. So by writing this, you take care of that, you take care of this, and you take care of where is cz? We don't have any cz.
Oh, wait, which one is it?
So it is ay, bx, so this we cannot write like that unless you subtract it again.
No, wait. I must have mixed up some terms in my calculations.
Okay, what about you? Yes?
I regroup them to in the order a squared y squared,
A squared y squared, yes.
b squared x squared,
B squared x squared.
and then minus 2
Yes.
ax by.
That is my intention as well. Okay, I think this is working now. So you are taking this one and that one and put them in one group, yes? And then you take the other, so I don't know which ones.
A
Yes.
squared c squared,
Yes?
and then c squared x squared,
Okay.
minus ax
2,
2ax c.
yes,
z.
2acxz. So this means that I took this one, and this one, and this one. And then the other 3 terms are together, yes? So then becomes plus, so this one, and which one? This one. So this becomes b squared z squared plus c squared y squared, and then minus 2bcyz, and this one. So I took care of all the terms, but now if I ask you what this is, then so this is greater than or equal to 0. Again, I write it again, but this can be written, hopefully you understand it immediately, that this is nothing except this one to power 2. Because this becomes the first one to squared, the second one is squared, 2 times the first one times the second one, which gives me this one, and the same combination for the others. So then it becomes az minus cx squared, and then this gives me bz minus cy squared, yes? Is it guaranteed to be true? Yes, because it is non-negative because of this even power, non-negative, non-negative. I am adding 3 non-negative numbers regardless of my choices for A, B, and C, and X, and Y, Z. Yes? So this is guaranteed to be true, but of course it is not finished if you have to be careful that all these steps are reversible. And I hope that you agree with me, everything that I have done, I can undo, yes? I will go back, yes? All of them are reversible, so it means that this is equivalent to this, and because we know that this is true, this has to be true, yes? So that is the proof of Cauchy-Schwarz inequality, French and German mathematicians respectively. Okay, but then let me ask you one question, which is always important. If I ask you, if I give you these 6 numbers, and instead of inequality, I put equality for you, and I ask you when the equality occurs. Okay, equality occurs if and only if what happens? Can you tell me? So I want to write the consequence, which is important for us. You will see why. Might be I will not be able to cover it this session, but this I want to complete it because that's a very important thing. So if I ask you, there are 6 numbers A, B, C, and Z, A, B, C, X, and Y, and Z, so that this is equal to A squared plus B squared plus C squared multiplied by X squared plus Y squared plus Z squared. I am asking you, this happens if and only if what happens? This you can immediately answer if you learn what I told you there about equality signs. When this equality happens, yes?
When they become 0.
When this becomes 0, which means each one of them has to be 0. So this happens if and only if AY is equal to BX and AZ equals to CX and ABZ is equal to CY. Agree? But I can do a little bit better. If A and B and C are non-zero, let us assume that A, B, and C are non-zero. Then here, what can I do? I want to show that this is the case. I want to show that X over A becomes equal to Y over B becomes equal to Z over C. That's a very nice way of writing this. Yes? But why do you think this is true? If A, B, and C are non-zero, I want to show that this is equivalent to this statement. Instead of memorizing 3 equalities, you can have a nice relation that you can memorize easily. So if I tell you that this is equal to this, and I guarantee you that A, B, and C are non-zero, then you can say that this cannot happen unless I have these 2 equalities. The ratio of X to A should be exactly equal to the ratio of Y to B, and it should be exactly the ratio of C to Z. Why do you think this is true? Because first of all, if I have this, because I want to show that this is equivalent. Equivalent means that I should assume that these are true, prove this, and I should assume that this is true, prove all of them are true. But if this is true, going back is easy. Because if I tell you that X over A is Y over B, then you can immediately conclude BX is equal to AY. BX is equal to AY. And you can conclude that XC is equal to ZA. And you can conclude that YC is equal to BZ. So you see, if I give you this, you can conclude all of them. But if I give you these, you should be able to conclude this one as well. But that is also clear, because this can be written in this form, yes? So AY/BX is exactly this expression, if A and B are non-zero. And this expression is equivalent to this part, and this expression is equivalent to this part. So that is a very nice relation, even if you don't want to memorize that, but write it somewhere because I want to use it. So if you see that this one squared happens to be equal to this product, you immediately can conclude this is not trivial at all. You can immediately conclude that the ratio of X to A, Y to B, and C to Z, if A, B, and C are all non-zero numbers, should be the same. Yes? And of course, if one of them is equal to 0, you cannot have that one. But this is always independent of writing it there. Because the interesting case are for the cases that A, B, and C are non-zero. This is why this is better to have. Okay, but let me tell you what is the connection of this one with the vectors. I will talk a little bit about the depth of this inequality later. It would be good to at least get some information about that. But here, let us immediately arrange it using a vectorial argument. I want to prove the same inequality using the tricks and techniques that we learned in vectors, which is probably completely different because vectors are somehow related to geometry, but might be you couldn't guess that you can sometimes solve inequalities using vectors. That is a very nice thing to do. How can I do that? At least I can tell you some ideas. If we cannot complete it, we can complete it later. So the point is that you give me 6 numbers, and I want to prove this. Okay, forget about the inequality. Just think about these 6 numbers. I take A, B, and C, and I introduce a vector. Yes, I say that let vector U be equals to A, B, and C. So be careful. You are giving me 6 numbers. I take the first 3 and put them in a triple, and I call it vector U. Yes, is that understandable? And I will do the same thing with a vector V, which I put X and Y and Z here. So you give me 6 numbers. I take the first 3, put them in a triple, and I call it vector U. And you give me these 3 numbers. I put them in a triple. I call it vector V. Yes? Now, can you tell me what is this combination in terms of vectors? Can you tell me what is the relation of this particular number in this box and U and V? What is this? Immediately you should tell me. AX, the first component multiplied by the first component, that's the dot product. And that is the dot product squared. So the left-hand side is nothing except the dot product of U and V squared. Yes? Agree? Less than or equal to. Okay, can you tell me what this guy is in terms of vectors that I introduced? A squared plus B squared plus C squared is? Yes, please tell me, the time is finishing. What is that? Yes?
It's norm of the vectors, right?
Norm of the vector squared, yes? Norm of vector U squared. And what is the other one? Norm of vector V squared. So that apparently complicated inequality can be written compactly in terms of vectors in this form. But is there a guarantee that this equality holds for vectors? By the way, let us get rid of these powers of 2 by taking the square root. But when I take a square root, I don't need to be careful about here because they are non-negative. But I have to be careful because U dot V might be negative. So this I have to put absolute value. So I hope that you agree, in the language of vectors, this inequality can be translated into this inequality among vectors. And then if I take the square root aside, this is equivalent to this one. So the matter, if this is true or not, if this is true or false, translates itself to this inequality to be true or false. But is this inequality true or false? Why is that?
Because cosine cannot be...
Yeah, exactly. So we are done. You see, because U dot V is nothing except U, norm of V, the cosine of the angle between them. When I take absolute value of this one, I have to take absolute value of this one. But this one is already positive, so I don't need to be worried. The only thing that I have to be worried is to put this absolute value here. But this is always less than or equal to norm of U, norm of V, yes? Because as Jonathan mentioned, this number is always less than or equal to 1. So then it means this one, no matter what I choose for U and V, is always less than or equal to this, but that is exactly what I want to prove. So you see, you didn't do any algebra. Yes, so you are using vectorial argument to just forego all these complications in algebra. So that is extremely important topic. I want to come back to it later, but I want you to at least see, because if I prove problems in geometry using vectors, it is more or less understandable, yes, because geometry and vectors are very related. But this is completely algebra for numbers, but you use the tricks for vectors to prove them. And actually, that was probably Cauchy and Schwarz were probably talking about abstract spaces. So that is, so you don't think that you deserve the name for the theorem because you were able to show that. They actually came to this argument from a deeper perspective, and probably we will talk a little bit about that later. Okay, but at least now we have a good point to stop here, because you understand that we can use vector arguments to prove inequalities as well. Yes, but this topic is not finished. I will come back to this after the break. Okay, thank you very much.